Geographers often study how landforms are made. To understand how these forces work, we must examine Earth's structure. The planet is made up of a solid inner core, a semi-liquid outer core, a liquid mantle, and then the solid outer layer is called the crust. Our continents, or land masses, are part of this crust. Geographers use this information and have formed a theory called plate tectonics. It suggests that our crust, or surface, is divided into slow-moving plates. Plates at our planet's surface move because of the intense heat at the core. That causes the molten rock in the mantle layer to move. It moves in a pattern called convection. These are the convection cells that go around in the circular pattern. When warm material rises and cools, it eventually sinks down. As the cooled material sinks down, it is warmed and then rises again. In this lesson, you will learn about the different plates that make up our Earth and the three types or ways the plates can move: divergent, convergent, and transform. This information is important for geologists because they are directly related to volcanoes, earthquakes, and tsunamis, and other natural disasters. I wanted to flip over. I've always been just fascinated by this time lapse from millions of years ago. This is by the California Academy of Science, and it is a time lapse of the Earth as the plates are moving. Check it out.
$200 million years ago, our world looked very different. India rubbed shoulders with Antarctica. Buenos Aires lay not far from Cape Town. And Morocco sidled up to New York City. The Atlantic Ocean started to open up around that time, beginning in the north. Tectonic plates moved apart and new crust formed in between. We can speed up time so that millions of years flash by every second. This change in tempo will allow us to witness geological time from our impatient human perspective. Europe, North America, and Africa split apart first, and as the southern Atlantic opens up, Africa and South America drift apart. The underwater ridge that traces the center of the Atlantic Ocean reveals the location of new crust forming. The youngest sections of the ocean floor lie nearest the ridge, with older, cooler, denser crust near the shoreline. The process seems smooth and stately from this perspective, but most of the plate's motion takes place in a series of adjustments we call earthquakes. Sometimes minute, sometimes monumental, these events shaped the landscape we recognize today.
5, 4, 3, 2, 1, present day. All right, so even when this video was made, the Earth has changed even more. So even though this is present day, the plates are constantly moving. So it is different every day. All right, let's get back to our presentation here, slide base. Oops, I clicked on the wrong one. Sorry. Present. Here we go. All right, so there's no specific order that we really need to go through on this. So I want to go ahead and start with the convergent first because I think it's the most difficult. It has the most components to it. We'll come back to the divergent and transform. But let's see, so the convergent, it can be categorized or broken down even farther. Convergent means to converge. So here is the picture here. The arrows are pointing next to each other, so it's colliding. And there can be three different ways that it can collide. It can be two ocean plates. So this is an ocean plate and an ocean plate colliding. So that's considered ocean-ocean. You can also have a convergent plate boundary of a continental plate, so land and ocean. So that one is called an ocean-land plate. And the third are two land plates when they collide, and that is called land-land. Ocean plates and land plates, or ocean land, ocean land, can get the ocean plate drops beneath the land plate to form a mountain range. The Andes in South America is an example of this plate colliding. And there's a picture of the Andes. So you can see the extreme when the plates collide. So this is the ocean and the land. And when it collides, it actually creates this mountain range right along the coastline. So these are the Andes Mountains in South America. And that happens because there is a boundary line of two plates that meet and collide right there. All right, so let's watch an example of an ocean-land collision or a convergent, because remember, we are on the second one, convergent.
White Island, as with all of New Zealand, sits right on the rim at the junction of the Pacific and Australian plates. It's a collision area where the floor of the Pacific Ocean dives deep below the Australian plate in what is called a subduction zone. The seafloor is buckled and pulled down into deep trenches, and the friction triggers powerful earthquakes as the Pacific plate is slowly consumed. Even here, magma flows from underwater volcanoes as rocks are melted and recycled. White Island is one of a chain of volcanoes that includes the notorious Tarawera.
That was quite a bumpy flight. But it's worth it because we're right on the Pacific Rim, though, aren't we?
We are. This is the Pacific Ring of Fire at its best. There aren't many places where you can see it so graphically.
So we're literally walking to the edge of the Australian plate, and right in front of us is the Pacific plate.
Well, not quite going that far. I mean, we really are entirely on the Australian plate here. But this is where we feel the effects of the downgoing Pacific plate.
And finally, we come to land-land. So we've looked at the ocean-ocean, ocean-land, and land-land under convergent, or actually we're getting to the land-land. Now, land-land are just what it is. It's the plates of a land, and they will collide to build a mountain. An example of this is the Indian plate crashing into the Eurasian plate right here. So that's the Indian plate, Eurasian plate, and it actually created the Himalayas. All right, so we are done with convergent. Let's go back up to the first one, divergent. As plates move apart, so this we've done convergent, they converge, they move together. Now we're doing, it's the opposite. It's actually the antonym of the second one, convergent. The divergent plate boundaries move apart. When that happens, gaps between the plates allow magma or liquid rock from the planet's interior to rise to the surface. Lava or magma that reaches the Earth's surface emerges from that gap and begins to form. The final way that scientists believe plates move is sliding past each other. So this is the third one, transform. You can see from the diagram here, it's two different plates and they slide past each other. So these move apart, these collide, and these move past each other. And that is called transform. This type of plate movement causes a lot of earthquakes to happen. An example of this is in California, where the Pacific plate is sliding by the edge of the North American plate. This has created the San Andreas fault zone, where earthquakes are quite common. The San Andreas fault zone is just one of many areas along the Pacific plate with frequent movement, which produces many earthquakes and volcanic eruptions. This area has been named the Ring of Fire because it is home to the most of the world's earthquakes and volcanoes. Let's check out this quick brain bite video to review before we launch into our quiz.
Located around the basin of the Pacific Ocean, the Ring of Fire is not really a ring, but more like an awkward horseshoe. It's home to most of the world's volcanoes, as well as 90% of the world's earthquakes. But why so many? Well, it's a result of subduction of oceanic plates beneath lighter continental plates. This animation might help clear things up. Thanks for watching. Subscribe to Brain Bites to stay up to date on the latest videos.
Brain bites are awesome, aren't they? Very quick. All right, so let's finish things up here. And we need to focus on the next part is getting to your quiz. So I want you just to recall for the quiz, make sure you understand the Earth's structure. Remember that it had that solid core, the different levels. The second thing are the plate tectonics. What are the three different types and their subcategories? The three forms of plate movement and their subcategories. So the land, ocean, etc. And some examples of each. And then also finally, what is the Ring of Fire? If you're a bit foggy on any of these, go back to that part in the lesson, review, and then go take the lesson quiz. It's time to head over to your lesson quiz in your agenda, and good luck.